Okay. So good evening once again to all of you students. So let's go ahead with the equilibrium lesson. Okay. So we have completed this very long back, right? So after your Diwali holidays, and this is the first class. So in the previous class, if you remember, we have discussed about the equilibrium lesson. And today will be the last class for this equilibrium. Okay. I will try to complete this by today. So we have covered almost most of the topics. Okay. So we have completed chemical equilibrium first, and then later we entered into the ionic equilibrium part. And also in the ionic equilibrium, we have covered what are electrolytes and acid-base theories we have discussed. And in the previous class, we have talked about the buffer solution. Okay, there were two types of buffer. One is acidic buffer and the basic buffer. And all the buffer actions we have discussed and all the examples we have discussed in that. Right. So in the previous class itself, I started the topic which is solubility product. Okay, so there were three topics under this: solubility equilibria and writing expression for solubility product, which is KSP, and the effect of common ion on solubility. So among these three topics, we have covered what is solubility equilibria in the previous class. Okay, so let me just go through the topic. So since it's been a very long gap, so let me go through the solubility equilibria again quickly. And then I will move on to the expression for KSP. Okay. So to understand the solubility equilibrium, we need to understand two terms. One is lattice energy and the other one is hydration energy. So if you guys remember, I told that lattice energy is the energy required to break 1 mole of the ionic compound in solid state to form the free ion, right? So I have taken NaCl, and this 1 mole of NaCl will be broken down and they will form Na plus and Cl minus ions. So the energy that it is absorbing and for the formation of this cation and anion is called as lattice energy. So since it is an energy absorption process, it is endothermic in nature and delta H will be positive, right? And the second term is called as hydration enthalpy. What it is? It is the enthalpy change when 1 mole of a substance or ion is completely hydrated by water. Okay. So if Na plus is reacting with water molecule, it forms aqueous Na plus. And here there is a bond formation between the water molecule and the free gaseous ion. Okay. And they are forming the hydrated ion or aqueous ion. So this is a bond formation process. So it is exothermic in nature. And if it is exothermic, delta H value will be negative. Okay. So this is about the lattice energy and the hydration energy. Now, coming to the solubility, I have given you the definition for solubility, right? So the maximum amount of solute that can be dissolved in a specified amount of solvent is called as solubility. So there were two cases. If the hydration or solvation enthalpy is greater than lattice enthalpy, the given salt will get dissolved. And in case 2, if the lattice enthalpy is greater than solvation enthalpy, then the salt does not dissolve. Okay. So using lattice enthalpy and solvation enthalpy, we are finding whether the given salt will get dissolved or it will not get dissolved. Okay. So after completing this solubility part, I have given you the classification of salt on the basis of solubility. Okay. So there are 3 categories under this. If the solubility value is greater than 0.1 molar, then the salt will dissolve. Okay, it is soluble. And if the solubility is in between 0.01 and 0.1, the salt will be slightly dissolved, slightly soluble. Okay, and if the solubility is less than 0.01 molar, the salt is sparingly soluble. Okay, with this only we have completed the previous class. Today, we are going to enter into the writing expression for KSP. KSP is nothing but solubility product. Okay, KSP is called as solubility product, and we are going to learn how to write or how to express the solubility product for the reactions. Okay. So first of all, let me give you a statement. A solubility equilibrium exists when a chemical compound in a solid state is in chemical equilibrium with the solution of that compound. Chemical compound in solid state, if it is in equilibrium with the solution of that compound, then there is a solubility equilibrium existing in that compound. Okay, so to understand this statement, I will give you a reaction. So see this. This is the chemical compound. BaSO4 is the chemical compound. Okay, and this chemical compound is in the solid state. It is in the solid state. And this compound is in solubility equilibrium. This compound is in solubility equilibrium with the solution of that compound. Okay, with the solution of that compound. So you see here, if I put this substance or the salt in the water, they will produce aqueous cation and anions. Right? Ba2 plus ion and SO4 minus ion they will produce. Got it? And there will be some solubility equilibrium existing between these two. So this is the meaning. Now, going ahead with this, initially, the concentration of BaSO4 is taken as yes. Okay, initial concentration of barium sulfate is taken as yes. And initially, there won't be any formation of product. So the concentration of Ba2 plus ion and SO4 minus ion is 0. Okay. And after some time, they will form the product. And once they reach the equilibrium, they will have some concentration, right? So equilibrium concentration is yes, 1 yes for Ba2 plus and 1 yes for SO4 minus. Because we are getting only 1 cation and 1 anion. So it is taken as 1 yes and 1 yes for both. All right. Now, if you want to write the equilibrium constant for this reaction, how will you write? So, we already studied about the equilibrium constant, right? Denoted by the letter K, and it is equal to the product concentration divided by the reactants concentration. Do you remember? The product concentration divided by the reactants concentration. So, using the same concept, we are going to write the equilibrium constant for this reaction also. So, K is equal to Ba2 plus and SO4 minus concentration divided by BaSO4 concentration. Okay. Now, what you do, take this BaSO4 to the other side. What will happen? We will have K into the concentration of BaSO4. Okay. So, this K into the concentration of BaSO4 is written as KSP, which is called as solubility product for that reaction. And the KSP value for barium sulfate is 1.1 into 10 to the power minus 10. Okay. So you don't have to worry about this value because it will be given to you in the question. Okay. And we know that the concentration, equilibrium concentration for barium 2 plus ion is yes. And SO4 minus ion is also yes. So S into S is S square. Okay. So 1.1 into 10 to the power minus 10 is equal to S square. And if I take the square root of this number, I will get the value of S, which is equal to 1.05 into 10 to the power minus 5 mole per liter. Okay. So this is how we are going to find out the solubility. S means solubility. KSP means solubility product. Okay. These are the two terms, very important terms involved in this concept. Okay. So you will get more number of problems, numericals from this concept. In some questions, they will give you the solubility product, KSP value. They will ask you to find out the S value like this. In some questions, they will give the S value and they will ask us to write the KSP value. Okay. So we can calculate both because we know one term and we can find out the other term using the known value. Got it? So this is how we have to proceed. So let me take one example for you so that you can understand it better. So I have taken calcium phosphate as an example. So calcium phosphate can be dissociated using 3Ca2 plus and 2PO4 3 minus, right? So you might have studied how to form the cation and anion for a given species. So if I have some compound with the AX and BY format, so how will it get dissociated? It is X into A power Y plus and Y into B power X minus. So this is how you have to separate, right? So here calcium is A and phosphate is B. 3 is X and 2 is Y. Okay. And using this formula, if you separate, you will get this. 3 into Ca2 plus and 2 into PO4 3 minus. All right. The initial concentration will be S for calcium phosphate and there won't be any concentration for the product. And at equilibrium, what will happen? We will have the concentration of the product. But here we have 3 cation and 2 anion. So it will be 3S and 2S. This is the equilibrium concentration. So now how to write the KSP? KSP is equal to the product concentrations raised to their stoichiometric coefficient. Now we know that the calcium 2 plus concentration is 3S and the phosphate concentration is 2S. Phosphate concentration is 2S. Now substitute these two values in the KSP. Substitute these two values in the KSP. So you will get 3S cube into 2S square. Okay. 3 cube is 27. 27S cube and 2S square is 4S square. 2 square is 4 and S square. Okay. And here bases are same, right? You can add the powers. So 27 into 4 is 108. So it is 108 S power 5. 108 into S power 5. Okay. Clear for all of you? Do you have any doubts in finding out the solubility product? So this is a relation. So if S is given to you in the question, you can find out KSP. If KSP is given to you in the question, you can find out S. Okay. Very easy. Any doubt in writing the KSP expression for different types of reaction, students? Bhavana, Jainvi, Vaishnavi, Priyadarshini, Vangtoi, Roshan. Can you able to understand how to write the KSP for the types of reactions like this? Give me your answers in the chat box. Roshan, are you there?
Yes, ma'am.
Yes or no? I'm not able to hear your voice. Okay. Any doubt? Any doubt for anyone? Shall we go ahead with one question? Okay. So let's take a question. The values of KSP of two sparingly soluble salts are given. Nickel hydroxide and silver cyanide. Which salt is more soluble and explain? So how to proceed? The KSP value is given. We have to find out which is more soluble. Okay. So let me proceed. If this kind of questions are asked to you, first of all, you have to take the compounds and you have to write the reaction for it. So if I take AgCN, it will be separated into Ag plus and Cn minus, right? And the KSP value, it is Cn minus. Okay, it is Cn minus. KSP will be Ag plus concentration into Cn minus concentration. And that is given as 6 into 10 to the power minus 17 for AgCl. Okay. And we know that the solubility will be S and S. So it is S square. So S square is equal to 6 into 10 to the power minus 17. And what is the value of S? We have to take the square root. If you take the square root for this number, you will get 7.8 into 10 to the power minus 9. This is for AgCl. Now coming to nickel hydroxide story, it will be separated into nickel 2 plus and 2 OH minus. Because we have only one nickel and 2 OH. So we have one cation and 2 anion. So the concentration, equilibrium concentration will be Sn 2s. Now Ksp will be equal to nickel 2 plus concentration into OH minus concentration, the square. Okay, now substitute the concentration values and you will get 4s cube. 2 square is 4. 2 square is 4 and here we have 4s square and here we have 1s, right? So it will be 4s cube. So Ksp is equal to 4s cube, which is equal to 2 into 10 to the power minus 15 for nickel hydroxide. All right. Clear for all of you? So if you bring this 4 to the other side and if you try to take the cube root for this number, you can get the solubility value as 7.9 into 10 to the power minus 6. Okay. So which is the very least number? Comparing the solubility of nickel hydroxide and the solubility of silver cyanide. Can you tell me? Solubility of nickel hydroxide is 7.9 into 10 to the power minus 6. And here it is 10 to the power minus 9. Which is the bigger number? Which is the bigger number of those two? 10 power minus 6 or 10 power minus 9? Yeah, it is 10 to the power minus 6. Nickel hydroxide is more soluble than silver cyanide because the solubility of nickel hydroxide is greater than the solubility of silver cyanide. Okay? Any doubt? Do you have any doubt from this concept? Shall we go ahead with the very last topic of the lesson? Okay. It is effect of common ion on solubility. Okay. Already we have studied one common ion effect in chemical equilibrium. So we are going to study the same thing for solubility concept also. So coming to the effect of common ion, let me take one reaction. I am going to take silver chloride compound and that will be in equilibrium with Ag plus ion and Cl minus ion. And if I take NaCl, that will produce Na plus ion and Cl minus ion. So in a beaker, initially I have silver chloride. So Ag plus and Cl minus will be there. And if I try to add some drops of sodium chloride solution, okay, sodium chloride solution, it will lead to the formation of some sodium plus and Cl minus inside the beaker, right? So which ion is common for both? There is one ion common for both the compound, right? Which is that? Can you tell me? Which ion is common for both the compound?
Cl.
Which ion is common for both the compound, students? So initially I have Ag plus and Cl minus. After adding NaCl, I have Na plus, Ag plus and more number of Cl minus, right? So the common ion between these two compounds is Cl minus. Yeah, the common ion is Cl minus. So this is the common ion. Got it? Now you have to think about the Le-Chatelet's principle we have discussed before. According to Le-Chatelet's principle, what will happen? The reaction will move towards the backward direction because in the product side, more number of Cl minus ions are produced. So to have the reaction in equilibrium, it has to come to backward direction so that some amount of some number of Cl minus can come to the reactant side. Okay. So according to Le-Chatelet's principle, if the product concentration is increased, then the reaction has to shift towards the backward direction to get the equal amount of ions. All right. This is the effect of common ion. Reaction will moving towards backward direction is the effect of the addition of common ion. Okay. Now, with this, we are going to learn one more thing, that is a condition for precipitation. So you all know what is precipitation, right? You all know what is a precipitate. Something which is getting settled down at the bottom of the test tube or the bottom of the beaker is called as precipitate. So when does a salt get precipitate? The conditions only we are going to learn now. We know that Ksp is the solubility product at equilibrium concentration. And I'm going to introduce one more term for you, which is called as Qsp. Qsp is called as ionic product at any concentration. Okay, Ksp is the solubility product at only equilibrium concentration. Qsp is called as ionic product at any concentration. Ionic product at any concentration. Now, using these two parameters, we are going to discuss when does a precipitate will form and when does it will not form. Okay. So, first of all, the first condition is if Qsp is greater than Ksp, precipitate will form. If Ksp is greater than Qsp, more salt will dissolve. More salt will dissolve and the precipitate cannot form that easily. Okay. If both the values are equal, then we can say that the reaction is at equilibrium. Clear? So these are the three conditions for precipitation. So if Qsp is greater than Ksp, precipitate will form. Keep that in mind, okay? So these are the three conditions. So with this, we are completing the chapter. Let me summarize the solubility product. So first of all, we have studied the expression for how to write the solubility product. And before that, I have discussed the solubility equilibria. Okay, when hydration enthalpy is greater, salt will dissolve. If lattice enthalpy is greater, salt will not dissolve. Then writing the expression for solubility product for any kind of salt of AX and BY type, the Ksp will be equal to x power x, y power y into x power x plus y. So you don't have to get confused with this formula. So if you apply this formula for any compound, you will understand. Otherwise, you just follow the step which we have discussed in the class. Okay. And thirdly, we have discussed the condition for precipitation. So when does a salt will get precipitated? When Qsp is greater than Ksp. Okay. So is it clear for all of you? Do you have any doubt from the session? Shall we go ahead with the ionic equilibrium previous year questions from this concept? Are you all ready? So we are completing the equilibrium lesson here. So let's go ahead with the previous year questions. Yeah. So this is the first question from buffer solution topic. An acidic buffer is prepared by mixing. Can anyone find out the answer for this? Acidic buffer is prepared by mixing. So I will give you 30 seconds to 1 minute time to solve this. So please find out the answer and let me know the answer in the chat box. Which option is correct? You can go through your notes also, if you have it. Find out the answer and let me know the option in the chat box. Acidic buffer is a mixture of. Acidic buffer is a mixture of. Option D, no. Option D is not the answer, my dear. What about others? Roshan, did you get the correct answer? Option D is not the answer. Did you arrive at the correct answer? Option A? Yes. Option A is the correct answer. So it is the mixture of weak acid and its salt with a strong base. Weak acid and its salt with a strong base. All right. So now let's go ahead with the second question. The pH of a solution containing 50 ml each of 0.10 molar sodium acetate and 0.01 molar acetic acid is pKa for acetic acid is given. We have to find out the pH. So how to find out and which formula you will use? Can anyone tell me the name of the formula? Can anyone tell me the name of the formula that we have to apply? Okay, you try for the answer. I will give you 1 minute to solve this problem. So get me the correct answer and try to get me the name of the formula also. Okay. We will solve after 1 minute. So we have sodium acetate, which is a salt, and acetic acid. So this is the acid and this is the salt. Okay. CH3COO minus Na plus. Sodium acetate and acetic acid means CH3COOH. Okay. So these are the two compounds and their concentration values are given. And pKa for acetic acid is also given. How will you find out the pH? So take your time. We will solve after some seconds. .57. Roshan, how did you arrive at this answer? How did you arrive at this answer? Which formula have you used?
Ma'am, pH equal to pKa plus log of salt concentration of salt divided by concentration of acid.
Okay, it is Henderson-Hasselbalch equation. Right? It is Henderson-Hasselbalch. It is Henderson-Hasselbalch equation we have to apply. Okay. So according to this equation, the pH for salt and acid can be calculated using pKa plus log of concentration of salt divided by the concentration of acid. Right? Do you guys remember this formula? Yes or no? So substitute the pKa value. pKa value for acid is 4.57 plus log of concentration of salt is 0.10 and for acid it is 0.01. 0.10 is actually 10 power minus 1 and 0.01 is equal to 10 power minus 2, right? Because here we are moving towards right towards 1 digit and here we are moving with the 2 digit. So it is 10 to the power minus 1 and 10 to the power minus 2. So if I cancel this, I will get 10 to the power minus 1 in the denominator So if that goes to the numerator, I will have log of 10 to the power 1. What is log 10 value? It is 1. So log 10 is equal to 1. So 4.57 plus 1 is equal to 5.57. So the correct answer is option A. Okay. Able to understand for all? Do you have any doubt? Do you have any doubt? Okay. So now let's go ahead with one more question. The pKb of dimethylamine and pKa of acetic acid are 3.27 and 4.77 respectively at a temperature, at some temperature. The correct option for the pH of dimethyl ammonium acetate solution is. So again, we are asked to find out the pH for the solution. Okay. And what is this dimethylamine? It is a base. What type of base? Weak base. And acetic acid is a weak acid. And the pKa, pKb value for the acid and the base is also given. Okay. If we combine dimethylamine and acetic acid, and if they both react with each other, they will form dimethyl ammonium acetate solution. Okay. And we have to find out the pH for it. So dimethyl ammonium acetate solution, actually this dimethyl ammonium acetate is a salt of weak acid and weak base, right? So for weak acid, weak base combination, the formula to find out the pH is equal to 7 plus half of pKa minus pKb. Okay, so we have studied 3 formulas, right? So this is the formula to find out the pH for salt of weak acid and weak base. Now we have all the answers in the, values in the question. We can substitute them directly here and get the answer. It is 7 plus half of pKa is 4.77 and pKb is 3.27. Okay. So what is the answer for this? 4.77 minus 3.27. It will be 0, 5 and 1. 1.5, right? So 1.5 divided by 2 plus 7. What is 1.5 divided by 2? Is it option A? No. 1.5 by 2. 7 plus 1.5 by 2. 1.5 by 2 is 0.75, right? So 7 plus 0.75 is equal to 7.75. Option D is the answer. Option D is the answer. Got it? Roshan, you have made some silly mistake in your calculation, I think so. That's why you have ended up with the wrong answer. Right? So option D is the correct answer for this. So everything is a direct substitution. Got it? So we are not calculating anything separately. So you just substitute the values given and in the formula which is appropriate to solve this question. Okay, so you need practice to solve such kind of question. Okay, if you practice, it will be easy for you. Got it? So let me go for the next question. The pH of a saturated solution of calcium hydroxide is 9. The solubility product of calcium hydroxide is. So we have to find out KSP and the pH value is given. So from the pH value, we need to find out the solubility, that is S. So only if we find out the S value, we can find out the KSP value, right? Because we know that calcium hydroxide can be separated like Ca2 plus and 2 OH minus. So we have one cation and two anion. So solubility concentration, the equilibrium concentration will be S for calcium 2 plus and 2S for OH minus. So we don't have the solubility value in the question. Okay. So only if we have the solubility, we can find out the solubility product KSP in the next step itself. But instead of giving solubility value, we are provided with the pH value. We can find out the solubility from pH. Okay. If the pH is equal to 9, what is the value of pOH? pOH will be 5, right? Because pH plus pOH should be equal to 14. Okay, if the pH is 9, what will be the value of pOH? It will be 14 minus 9, right? 14 minus 9, so it will be 5. pOH is 5. pOH is 5 means the concentration of OH minus ion is equal to 10 to the power minus 5. 10 to the power minus 5. Okay, concentration of OH minus ion is 10 to the power minus 5. Because we know that pOH is equal to minus log of OH minus concentration. So only if I have OH minus as 10 to the power minus 5, pOH will come out to be 5. Got it? So 10 to the power minus 5 is the concentration of OH minus. Clear? But the OH minus concentration is 2 OH minus. So what I have to do? So it will be 2S. The concentration is 2S. So 2S is equal to 10 to the power minus 5. So what is S? S is equal to 10 to the power minus 5 divided by 2. So this is the value of S. This is the value of S. Now you can substitute this S in the KSP relation. We know that KSP is equal to concentration of Ca2 plus and concentration of OH minus square. So for calcium 2 plus it is S, and for OH minus it is 2S the whole square. So 2 square is 4 and 4S cube we will get. 4S cube we will get. 4S cube we will get. From this, substitute KSP is equal to 4 into S is 10 to the power minus 5 divided by 2, the whole cube. The whole cube. And if you solve this, here we will have 8. So it will be 10 to the power minus 15 divided by 2. 10 to the power minus 15 divided by 2. Okay. So, you know how I am doing, right? So let me erase and do it for you. Excuse me. So Roshan, are you getting? That's great. So let me show it for others also. So if I substitute the S value, what I will get? 4 into 10 to the power minus 5 by 2 the whole cube. So if I take the cube of this, I will get 4 into 10 to the power 5, 3. Okay, so it will be 15 divided by 8. 2 cube is 8, right? So it will be 10 to the power minus 15 by 2. So 1 by 2 is nothing but 0.5. So it is 0.5 into 10 to the power minus 15. Okay. So which is the value for KSP. Okay. So option C is the correct answer. Option C is the correct answer for this question. All right. So let's move ahead with the next question. The solubility of barium sulfate in water is 2.42 into 10 to the power minus 3 gram per liter at 298 Kelvin. Solubility is given. What is the value of its solubility product? So we are provided with S value and we are asked to find out the KSP value. Molar mass is also given. So how to find out? The solubility of barium sulfate is equal to 2.42 into 10 to the power minus 3 gram per liter. But in all the cases, we have the answer in terms of mole per liter. So first of all, we have to convert this solubility in mole per liter from gram per liter. Okay. So to convert the solubility in mole per liter, first of all. So to convert that, what we have to do? Solubility is equal to the given mass is 2.42 into 10 to the power minus 3. Mass by molar mass. Molar mass is 233. So if you divide this number by the molar mass number, you will get one value and that will be the answer in terms of mole per liter for solubility. Okay. So I am dividing by the molar mass and getting the answer in terms of mole per liter. So I have the S value now. Now we can proceed. BaSO4 can be separated as Ba2 plus and SO4 2 minus. Okay. Now the KSP will be equal to Ba2 plus concentration into SO4 2 minus concentration. So we have one cation and one anion. So both the concentration will be S and S. So it will be S into S, which is S square. So we have the S value in our hand. Just substitute 1.04 into 10 to the power minus 5, the whole square. Okay. So if you take the square, you will get 1.08 into 10 to the power minus 10. Okay. It is 5 into 2, right? It is 5 into minus 5. 10 power minus 5 into 2. So it is option A. 1.08 into 10 to the power minus 10 mole square per liter square is the answer. All right. Do you have any doubt? So if you want to convert gram to mole, just divide by the molar mass. So that will give you the answer in terms of mole per liter. Shall we go for the next question, students? Okay. So here is a question. When the hydrogen ion concentration changes by a factor of 1000, the value of pH of the solution is. So how to find out the answer? So let me take the initial concentration of H plus as 1. Okay. Let the initial concentration of H plus be 1. Initial concentration means it is a H plus concentration. Initial concentration is equal to 1. If the concentration of H plus is 1, so using pH formula, which is actually equal to minus log of H plus, if I substitute this H plus as 1, I will get log 1. Log 1 is equal to 0. So pH will be equal to 0. Okay. So this is my assumption. Initially, I'm taking this as 1 and I'm getting the pH as 0. Now what I'm doing? Now I'm changing the concentration of H plus by a factor of 1000 according to the question. Okay. So now it changes by 1000 units. 1000 means it is 10 to the power 3, right? 10 to the power 3 units. So therefore, the final concentration of H plus is equal to 10 to the power 3. So if you substitute in the pH formula, what will you get? pH is equal to minus log of 10 to the power 3. The answer will be minus 3. Answer will be minus 3. Okay. So initially I have pH value as 0. After doing this conversion, when the concentration is changing by 10 to the power 3 unit, the pH is coming out to be -3. So minus indicates the decreasing thing, and 3 means it is decreases by 3 units. So option C is the correct answer. So it is changing from 0 to -3. Okay. So the value of pH of the solution decreases by 3 units. Do you have any doubts? Can you all able to understand this question? So you can take any number as an assumption, okay, for concentration of H plus, and you can do for the remaining. Okay. Any doubt, students, for anyone? Clear? Okay. So this is all for today. So today we have successfully completed the equilibrium lesson, and from next session onwards, we will start with the new chapter. Okay. Do you have any doubts from the equilibrium lesson, from ionic equilibrium and from the chemical equilibrium? Do any of you have any doubts from the equilibrium lesson? Please go through the lesson, revise the lesson, and go through the problems that we have solved, and try to write all the formulas in a formula notebook, which I have asked you to put in the beginning of the class itself. Okay. And maintain a small notebook, small formula notebook, and revise all the formulas. Okay. By doing so, you can get a very good marks in both thermodynamics as well as in equilibrium lesson. Okay, so these are the two very important physical chemistry lessons of class 11. Okay. So thank you so much for attending the today's lecture, students. I have launched a poll for you guys.